All right, so we're starting back on the 6-2 notes. Picking up if a equals 1 is a factor, or does not equal 1, pardon me. We're going to factor the leading coefficient from the quadratic and the linear terms before we complete the square. All right, so it does, like I said, it's a little trippy in completing the square. It's on the second page in the middle. Nope, sorry, I guess technically third page if you're looking at it this way. Yep, okay. All right, so we've got this function here, f of x equals 3x squared plus 6x minus 2. So we always want to try to factor out that leading coefficient. Always, always, always. So in this case, I factored out the 3, which was the leading coefficient, left us with x squared plus 2x. But notice I took the minus 2 out. Okay, previously we haven't done that. We've tried to factor it out of all 3 terms. But we don't care about the third term. We just want to factor it out of the quadratic term, which is the first one. It has the x squared, and the linear term. Because we're going to add that b divided by 2 squared, and then we're going to turn around and subtract it as well. But here's the thing. Okay.
Because the original is 3x squared.
Yeah, here's my original.
No, not the 3 on the left, the 3 on the right. That's...
Oh, further down?
Yeah.
You're ahead of me. Okay.
Well, I was just looking at it.
You're good. You're good. That's okay. Okay, so I factored out this 3. Okay. And then if you notice, I added my 2 divided by 2 squared here, which is my b term. Okay. Here's the thing we have to think about, and this is again where it gets trippy. If I do that, if I add this here, but this is being distributed, is this being distributed to this? It's inside the parentheses, so it will be distributed, which means when I subtract at the end, I have to also subtract the 3 that's being distributed and the 2 divided by 2. No, because see this, it's minus 3 because it's subtraction, and then this is going to be distributed to that quantity once I do it, just like it is here. So we have to subtract. When we factor out, we also have to then distribute this quantity to the amount you subtract from the constant. That's what that note is all about. It's that step right there. Okay, because we leave it out. We leave this term out because that's going to become our a term. Okay, and then we completed the square, like the part in here that's the completing the square part. We did that so we could get our binomial that's squared. That's why we have to complete the square. So the 2 divided by 2 was just 1 squared. And then our minus, so there we have, right, the 1 is, or which is actually our x plus 1 becomes our h value, the minus 1. And then we do the minus 2 minus 3, that's at the end, right, because 2 divided by 2 is 1, 1 squared is 1, negative 3 times 1 is negative 3, which brings us to negative 2 minus 3, which is negative 5, and there is our k value, the negative 5. So all the parts and pieces have a purpose. It's just this step is the hiccup, because we have to remember to distribute this factor. We factored it out of the first 2, but we have to distribute it as well at the end. Because if we worked it backwards. Why do we have to factor it out? So we can get our a. Well, sometimes there's not. Well, yes, you will. We will always be able to factor it.
If it's 3x squared and then 5, you can't factor 3 out of 5. You can't always factor it out.
But that's the thing. We can always figure something. We'll get there. Yeah, like you're looking ahead. Yes, Elaine. Yes. Okay, so we will get there. We're not going to start with the hardest ones. Okay. So let's try this on the next one, example 5. We're graphing f of x equals negative 3x squared plus 6x plus 1 and state its vertex and the axis of symmetry. So can we get this in vertex form is what we want to do. Okay, so I'm just going to take the f of x off. We're going to start with the negative 3x squared. Okay, yeah, plus 6x plus 1. I just wanted to make sure it wasn't the same one that I just had up here. And I was like, wait, we've already done all the work. We just need to graph it. Okay, so we're going to focus on the first two. What can we factor out of there? Negative 3. We always want to take it as a negative. If this is a negative, we want to take it out. So negative 3x squared divided by negative 3 just leaves me with x squared. How about what's 6x divided by negative 3? No. Negative 2. Okay, so we'd have negative 2x. There's my parentheses, okay, plus 1. So this step was all about factoring out the 3. We good so far? All right, so now we're ready. We're going to take this, negative 3 times x squared minus 2x, and I need to add the b over 2. So we're going to add, what's my b value?
Negative 2 divided by 2 squared.
Okay, so b, right, is negative 2 still. So we've got negative 2 divided by 2 squared. Okay, we're going to close that up. That's the wrong color. Then we're going to add 1, because that's there. Now we need to, okay, so we need to bring this negative 3, right? Well, so we're going to subtract, okay, a negative 3 times my b divided by 2 squared. So the negative 2 divided by 2 squared. There was a lot there. But we moved to that step where we have to take, even though like when we factored it out, we had to distribute it over here because it's going to be distributed there. That's the super trippy part. Okay, so then we have negative 3 times the quantity x, what? What's negative 2 divided by 2? Negative 1. So it's going to be x minus 1 squared. And then let's do some math over here because I'm running out of room. All right, so let's see. What's negative 2 divided by 2? Okay, negative 1 squared. Negative, okay, so 1 times negative 3. Negative 3. So what is minus a negative 3? So it's going to be 1 plus 3 is 4. So there is our vertex form. So let me move up our graph. We've got our vertex form. And let's graph it. So where would our vertex be?
Where's our thing?
It's down at the bottom.
Negative 3 should be negative 4. Or sorry, 4. 1, 4.
Okay, I need to hear somebody else besides Josh, because apparently Josh gets it. So at this point, we've got our vertex form is f of x equals negative 3 times x minus 1 squared plus 4. So where did you say the vertex was, Josh?
1, 4.
At 1, 4. So we go 1, and then 1, 2, 3, 4. But what other numbers do we want? Like we talked about this table earlier. So if our vertex is at 1, so what's before 1? 0. And what's the number before that? Negative 1. What's the number after 1? 2 and 3. There we go. Okay, we can kind of set up our table around our vertex because we know this is 1, 4. So we're going to have negative 3 times what, Brandon? Keep going. Okay, squared plus 4. So negative 1 minus 1 is negative 1 minus 1.
0.
Not 0. Because we're negative 1 and we're going more to the negative. Negative 2. Okay, so negative 2 squared is? Nope, negative 2 squared. Negative 2 times negative 2 would be 4, positive 4. So then we've got negative 3 times 4 plus 4. So what's negative 3 times 4?
12.
Negative 12. Negative 12 plus 4 is? Negative 8. Okay. And so I'll erase this work so I have some room. So, Ethan, negative 3 times the quantity? We're doing 0.
4.
Okay. So 0 minus 1 is? Negative 1. Negative 1 squared is? 1. What's negative 3 times 1? And negative 3 plus 4? 1. Okay. Now, we should. So we did the ones on that side. Let's do the next one. So Josh, negative 3 times?
2 minus 1 squared plus 4.
Okay.
2 minus 1 is 1 squared is 1 times negative 3 is negative 3 plus 4 is 1.
Okay, I got the same number on both sides of my 4. So this is working out that I'm going to see my parabola. Okay. All right, so let's try the next one. So I've got negative 3 times 3 minus 1 squared plus 4. 3 minus 1 is 2. 2 squared is 4. Negative 3 times 4 is 12. Negative 12. Negative 12 plus 4 is negative 8. They're the same. Like, it's created this mirror image already.
And I think that's part of the problem I ran into is I was always trying to mirror it around 0 instead of the vertex.
Okay.
I wasn't thinking about that.
Yep. Yeah, so, and that's an easy hiccup. So then if we graph it, we've got negative 1 and negative 8. So negative 1 and negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And 0, 1. And 1, 4, which we've got. 2 is 1. And 3 is negative 8. It's real skinny, right? So let's check some things. Okay? Does it open down? Yes, check. Its absolute value is 3. So is it really skinny? And it's pretty thin. Okay, check. We got that one. Its vertex was 1, 4. We did that. Okay, like, so your stuff, all of the stuff from the equation matches your graph. It's like everything came together and it was like, oh. Mm-hmm. Mm-hmm. All right, so let's, I'm trying to think. Because we have some formulas we can use for H and K as well, but those aren't necessarily necessary for us, and class is almost up. So let's stop there. And